Use an appropriate triangle or trigonometric identity to rewrite the following as an algebraic expression in terms of x. So we've got a trig function nested inside another trig function. Remembering that trig functions get applied to angles, I'm going to say that tan inverse of x is an angle. I'll call it theta. So theta is the arctan or tan inverse of x. Now from the acronym SOHCAHTOA, sine has a formula of being the opposite leg over a hypotenuse in a right triangle. Cosine theta would be the adjacent leg over the hypotenuse. And then tan theta is the opposite leg over the adjacent leg. So since they're looking for arctan of x, I can draw a triangle in which x represents the opposite over the adjacent. I'm just using this identity here, that a tan of theta is opposite over adjacent. If we solve that, we would get that theta is the tan inverse of the opposite over the adjacent. That's what we have right here. We're taking an inverse tan of x. And here we're taking an inverse tan of opposite over adjacent. So it follows then, if we follow the pattern, that this x is in the place of the opposite over the adjacent. With that in mind, we can make this x over 1. And so if we go to make a triangle for this situation, what we'll have is the opposite side of the angle theta needs to be x. And the adjacent side needs to be a 1. This would allow us to solve Pythagorean theorem for the length of the hypotenuse in terms of x. So we have that for the Pythagorean theorem, a squared plus b squared equals c squared, where the a could be the adjacent leg, b could be the opposite leg, and c could represent the hypotenuse. So we have 1 squared plus x squared equals c squared. If we take a square root of both sides, this tells us c is the square root of 1 plus x squared. Now we can write that in. And so now we have to remember that I defined theta as the arctan of x. And what this problem's asking us to do is find the cosine of the arctan of x. So they want us to find cosine of theta. If we look at our angle and the legs of the triangle that contains theta, we would now use the definition of cosine theta as adjacent over hypotenuse. And so now we can divide the 1 by the square root of 1 plus x squared. And that's the answer to the question.